So let's sort of talk a little bit about what are some do's and don'ts, common patterns for what we see for loading data into Redshift. Now, Redshift is very suitable to hold raw and unstructured data, and planning a little bit upfront about how to manage very long tables is important to help to reduce pain down the line. So, uh, when moving data in, I think it's important to keep it as raw as possible, to not do any transformations, because you can do those transformations in Redshift. There's some exceptions, but some of the things that you should be doing and looking at is around making sure that all the timestamps for any table that has time series columns are the same. Taking care of time zones and datetime formatting is going to help prevent a lot of pain later. Number two is validating strings, right? I mean, if something's easy to do, do it. Email addresses, websites, etc., UUIDs, you can validate those values on the way in so that you're not having to clean that up later. And then don't, one thing that we've hit often is that if you're storing multi-byte characters in Redshift, if you're for either a column name, you can even actually use multi-byte characters for table names. Don't use a char data type, because you can't store multi-byte characters in those. So if you're having a column storing a list of tables in a char, and then somebody starts to or tries to input a multi-byte character, it'll fail. So the really important thing to remember as well with Redshift, if you're a first-time user, is that primary keys are not enforced. Now, you can assign a sort key and a distribution key in Redshift, but the sort key and the primary key is not enforced by the database. So you're responsible for deduplicating. Redshift will very happily duplicate rows, 2 rows with the exact same values. And so the recommendation is to use an upsert method in order to deduplicate rows on the way in. So that's really important to remember. Now, for really long tables, you might want to copy data in sort order. So vacuum sorting tables, which is an operation that you can do in Redshift in order to make it easier to filter and faster to filter on those tables, is a pretty expensive operation for very long tables. There's ways where you can ensure that you don't have to resort a table that has a time series column, for example, as a sort key, if you're able to copy that data in sort order from the beginning. Now, you can't use upsert with this process is not compatible with using upsert in some cases, and so you have to make sure that you're not attempting to copy and duplicate rows in sort order. And then finally, you got to make sure to use change data capture. So we have seen environments where their data loading process involves dumping the entire source database into Redshift and then deleting the data that's not needed, and then only keeping things that have changed. And that's a big problem, because Redshift is not optimized for loading data in. The copy statement is really good at parallelizing that process, but in general, you only want to move data in that you want to minimize the number of rows or optimize the rows that you move in. So making sure that you're only copying in data that's changed for incremental tables is key, is really important. That's also going to help you maintain a consistent disk utilization over time, which is going to mean that you spend less money on storage on Redshift, because you don't have to keep as much storage online as the peak required for a massive data load.